both Dr. Associate Professor Dr. Tinagaran Perumal and Dr. Edward Fedian, yeah, who have actually agreed to share their knowledge and expertise today. So their contributions hopefully we can help us to understand, to help us understand the potential of AI and its impacts on society. To avoid unnecessary delays, I think I won't take up much time. Yeah, I just want to send the Dean regards to all of you. Yeah, the Dean is not around. Is away. So with that, I hope we can explore more collaborations under the MOU that's signed between us. Yeah. So I will now hand it back to the moderator for our main event, the webinar series. So I pass back to Dr. Hamidah.
Thank you, sir, for the amazing speech. Ladies and gentlemen, before starting the main session, of course, we would like to capture this great moment because we would like to invite every one of you to join us in a photo session. As we have some slides here, we would like to kindly invite every one of you to activate your camera. We believe this is a great chance for us to gather here to talk about the insights, and it's going to be one of the memorable moments for every one of you as the witness that you join one of the very extraordinary moments to discuss with. So please kindly activate your camera, and we would like to invite the operator to capture this great moment. Okay, so ladies and gentlemen, please show your sweet smile to the camera before starting the session, because we believe starting everything with a very sweet smile is going to make your session brighter. It's going to be more interesting, of course, for every one of you and give the positive vibes. So we'd like to invite every one of you to open up your camera and show yourself here. We come from different countries. We believe that we are going to be the family here, and we're doing to have more collaborations, of course. So activate your camera. We're going to count 1, 2, 3. All right, so 1. Oh, wait, we're still on the process of activating. More 1,000 participants are activating the camera on the process. Okay, so I'm going to count 1, 2, 3. Please kindly give your sweetest smile here. 1, 2, and 3. All right, so still on the process of activating the camera, but well, we're going to give the second chance for every one of you guys to activate the camera, and please kindly show your thumbs up to the camera as showing that you have these positive vibes and you are ready for this insightful moment. All right, so you can show your thumbs up the camera as the sign that you are ready for this. Okay, maybe for some young generation, rather than thumbs up, you can show up the like this one. It's like saranghae in Korean style. All right. Oh, I guess every one of you guys mostly love this hand gesture. Okay, you can show the hand gesture to the camera. Okay, 1, 2, and 3. That's amazing. That's amazing, ladies and gentlemen. Let's give applause for every one of you. Wow, we believe that this afternoon session, it's challenging, yet it's interesting because everyone is getting ready. Everyone is ready for this amazing discussion with our prominent speakers. So once again, thank you, ladies and gentlemen, for joining us in this photo session. Ladies and gentlemen, we all know that it seems a bit difficult for some people to connect with each other in physical events, right? Especially when we come from different countries with a very miles away in distance. However, this barrier gets eliminated in the use of technology platforms such as webinars. People can ask questions, participate in polls, and also take a part in the discussion. This is a great way of engaging with others, learning, and growing. Therefore, the next session will be the great time for us to engage, learn, and grow together, grasping much knowledge from the prominent speaker in the first webinar session. So we would like to invite every one of you to take a part in the discussion by delivering your question, either by delivering it directly to the speaker or typing it on the chat box. And we would like to make sure that every question will be delivered to the speaker. Don't forget that the committee actually has provided some interesting souvenirs, the prize for everyone, or maybe for some interesting questions in the question and answer session. So please get the chance and grab the souvenirs from the committee. So ladies and gentlemen, let's start the function. In this first session, we'll learn about consumer-centric Internet of Things, the next big thing. This session will be presented by Associate Professor Dr. Tinagaran Perumal. Before welcoming the speaker, please allow me to introduce the speaker to every one of you. Okay. So Associate Professor Dr. Tinagaran Perumal is a recipient of 2014 Early Career Award from IEEE Consumer Electronics Society for his pioneering contribution in the field of consumer electronics. He completed his PhD at University Putra, Malaysia in the area of smart technology and robotics. He is currently an associate professor attached with the Department of Computer Science, Faculty of Computer Science and Information Technology, University Putra, Malaysia. His research interests are towards interoperability aspects of smart homes and Internet of Things, activity recognition for ambient intelligence, and cyber physical system. He has received 4 Best Paper Awards. Dr. Tinagaran also has delivered 10 keynotes and served 5 panels at various international conferences. And I guess it's going to be more, of course. All right, so ladies and gentlemen, without any further ado, let's welcome Associate Professor Dr. Tinagaran. Time is yours, sirs.
Thank you. Thank you, Ms. Moderator, Yayan Hamida. Let me share my screen. Salam Shatra and very good afternoon. Okay, in the next couple of minutes, I'm just going to take everyone to explore a bit on consumer-centric Internet of Things, the next big thing. We will see in a glance some introductions on Internet of Things and how it's influencing the consumer-centric ecosystems, a bit of key components for IoT that everybody looking forward to learn, and very important aspect on the revolutions and what we are facing now at the moment and how we can relate to artificial intelligence. And we will finally look into some application in various domains and perhaps some takeaways right after the webinar today. So assume that everybody is aware, okay, what is Internet of Things all about. It's not a new field, and it's been there since 1998. It's just that it's becoming a strategic technology trend in the recent years. And we could see that how Internet of Things have revolutionized the way we look at research domains, especially in industry and particularly related to the field of computer science. So definitely it's going to be a game changer with a lot of significant impact. And some of the industry pundits are expecting that this is going to be a $1 trillion market, and that's what we are trying to justify, that how we are seeing Internet of Things in the coming years. So before we embark on the concept of Internet of Things, it's very important for us to understand about the Internet of Things objects. Basically, we can cluster the IoT objects into 3 different categories. The first category is actually passive objects, where it's very much similar like our smart card or any pointers or tags that normally has some contextualized informations, at most some bit of informations like location and so on. So surrounding us, we are dealing with a lot of passive objects actually, especially with our bank cards, your credit cards, anything to do with information storing. And the second category is actually the reactive objects. This is also very common IoT objects in the ecosystems. Something to do with the switches, buttons, a smart meter, and very common we can see in home appliances where you can switch on your aircon by using a remote control, or probably you can turn on your digital setup box while watching your TV. So these are very common reactive objects, and we perceive them as reactive objects in Internet of Things settings. And the third one, and this is something, the vision, what we can say the vision of Internet of Things is what we call as autonomous objects. And we could seldomly see autonomous objects around us because there are not much autonomous objects available at the moment, but industry pundits and academics are actually moving towards that. So vending machines, or probably we can say that self-driving car or driverless car like Tesla, they all comes under the same category called autonomous objects. Even an intelligent fridge that can tell you what are the groceries items going to be expired and to which particular market or hypermarket that you need to contact, or probably the fridge will do the ordering system by itself. So this falls under the autonomous objects. And this is not an easy task because a lot of constraints that we have especially in developing autonomous objects. However, a lot of works are ongoing at the moment, especially in research areas that actually embarks on the use of AI relating with IoT. And we will see that in a couple of minutes. So to understand better, I think it's very important to grab the concept of IoT objects. And if you look at the concept or the definition of the IoT object itself, that you have some transformations of the devices. So it could be a watch, couple of sensors. So probably humidity sensors, temperature sensors, accelerometers. And when you combine those sensors with the device and provide them with their own internet protocol address, and that's how these devices become an IoT objects. So these IP addresses are meant for the internet connections. And normally the objects could refer to any physical objects with a device that has its own IP address. And they could connect by sending, transmitting or receiving data via any of the preferred network. So having IoT objects is very important because they actually are shaping up the entire ecosystems. And we expect to see a lot of IoT objects surrounding us in coming years. So if you look at the perception of the consumers, right, be it a normal user, end users, or probably industry practitioners, everybody has their own perceived definitions. For instance, you could ask a medical practitioner, they could see an IoT as the clinical connectivity. Probably they'll be dealing with some databases and some medical devices that need to collect some data and then try to store them in the cloud. And if you ask some of the system integrators who works in buildings, who works in the facilities, they would see IoT as merely a data collection mechanism. So different stakeholders are seeing that as a different definition. But I think it's very important for us to see holistically what actually IoT meant, right? So coming back to the core definitions as coined by the IoT European Research Cluster, and a lot of work comes actually from the European research clusters, where they see that IoT as holistically encompasses a lot of network infrastructures that comes a bit with the self-configuring capabilities, and of course, which is based on some standards and interoperable communication protocols, and they have their own identities, physical attributes, and virtual personalities. And of course, the very important thing that with the definition is that they have to use some sort of intelligent interfaces, and they need to be seamlessly integrated. So these are the generic definitions. However, many of the telecommunication providers are looking at as an infrastructure. Okay, they're looking at IoT as an infrastructure. So, like for instance, like a better, I think, a very solidified justifications about IoT definitions is given by a standard, okay, the IEEE P2413. It's actually a standard document that actually talks about the architectural framework for Internet of Things. So where they define that an IoT system is a network of networks where typically a massive number of objects, things, sensors, or devices are connected through communications and information infrastructure to provide value-added services via intelligent data processing and management. So the keyword here is actually the intelligent data processing and management. And of course, for different various applications, as we can just name it like smart cities, smart health, and so on, right? So it's very important to take note of the keyword, especially any IoT system should somehow correspond to the intelligent data processing and management. And interestingly, throughout the years, the definition has evolved, and we see that today, even though we say that the IoT system has to have some degree of intelligent features, and today this has been evolved to what we see as artificial intelligence of things, where we don't see an IoT ecosystem merely connecting each other, or probably collecting a simple sensor data, storing them, processing, and analyzing, and finally do some sort of control. But today, IoT objects and IoT devices are expected to selectively collect those data by using the capabilities of AI, storing them in the cloud, processing them, analyze, and act upon some predefined or predictable conditions. And this is what that makes the difference between the previous justification that we see in the last 5 years and what we have today. So the role of AI has become very important today, that it actually pushes the IoT to the edge. And you see that many IoT systems today are actually bypassing the cloud, and they could actually process, they could have the capability to process the data by themselves. And this is one very, what we can say, a catalyst mechanism by the AI in pushing IoT to the edge. So the concept here is that we have an object, that objects can be sensors or actuators with their respective IP address that could be connected to the internet throughout the 24 hours. And these can be connected to the local network, which could be wired or wireless. And of course, those data could be pushed to the cloud services. And these data either sent or received from the cloud, for instance, machine activation in the form of workflow, and most probably it could be analytics. And as what we see today, the analytics is very prominent in IoT. And of course, there is a global network that could actually become a connecting bridge between this local network, between the services, and how they can bring the services to the consumer side, right? On the consumer side, you have various enablers like smartphones, devices, wearables, and so on. So to understand the notion of the consumer-centric Internet of Things, I think it's very important to see how the consumers like to have the convergence of technology, the telecommunications, the data, and the consumer itself. And this could heavily influence the consumer industry in upcoming years. And what we expect is that the consumer values for IoT could be something they need or something that can be complicated. Just like that we have received mobile phone as part of our personalized device, there could be a time where IoT devices or IoT objects could be personalized and could be received by the users as they did for the mobile phone. However, this could take some time because a lot of constraints has to be break down, and normally consumers and users, they prefer something that has human touch. And that's what we call as the humanization of technology. So it could be in the areas like food, comfort living, environment, communication, convenience, and so on. So why we call this as the next big thing? There are many reasons. Of course, the first reason is about the applications, because the Internet of Things are normally motivated by the actual problems in key domains. The reason is because in practically the real world is a great test bed. We have a lot of problem statement out there, and when you have an IoT with AI, this definitely could provide you an obvious evaluation metrics. And of course, the impact is that the real problem, the real research problems, could have more interested parties. However, there is always must be a balance in driving the research by making computer science significant contribution. And this could facilitate cross-cutting application-driven research. So there is a very good infographic that I could share with everyone today. It's called as a Libelium Smart World infographic, and Libelium is actually IoT solution providers, and they come up with some of the out-of-the-box use cases. For instance, how to use IoT for air pollution, how to use IoT for forest fire detections, structural health, waste management, water quality, and so on. So this is a very comprehensive infographic that could be could be something that we can relate with real world problems. And the next reason why we call consumer-centric IoT is a big thing is because of the scale. Because the broad range of applications that we can work on, right? For any computing applications or computer science related research, we always expect an end product is to be an application, right? So we borrow the analogy from the software development where the application could be, of course, the whole point. And this has been said by Mark Weiser in his prominent paper about some computer science issues in ubiquitous computing back in 1993. And this has been a strong reference for many of the IoT applications still today. So many areas like outdoor and environment monitoring, building and energy, safety and security, industrial and infrastructure, urban areas, healthcare. So it could be not just the application overviews, but we could expect that there could be some specific research systems that could address specific aspects of the larger problems. So there is a broad vertical and horizontal applications that we could indulge in consumer-centric IoT. And the third concrete reason why we call the consumer-centric IoT is the next big thing, because it cut across the computing stack. So if we look at the computing stack, and we could define the layers of the IoT stack here. So from bottom to the top. So on the bottom level, we have the low-level devices, the physical layer, especially what we call as embedded systems, that deals with hardware primitives, basically microcontrollers, memories, power supplies, and trusted platform modules. And we have specific hardware platforms and embedded systems, kits, environmental sensors, wearables, energy meters, and so on. And we have operating system as part of it, where we deal a lot with the device programming in the field of security and updates, patching, and so on. And then we have this middle layer we call the connectivity, the gateway, that deals with a lot of protocols. And apparently there are plethora choices of protocols for IoT. And it's just a matter of what type of applications that we need to define, especially in selecting the right protocol. So BLE, Bluetooth for low energy, Wi-Fi, 4G, and so on. And then you have the ensemble programming. If then what, then that is like something like data flows. Excuse me. And then you have like the cloud, the data storage, the cloud compression, security, and so on. And the top layer would be the data analysis, where we deal with the machine learning, deep learning, and trend analysis. Apparently, the focus in computer science are more towards the data analysis. Of course, there are many other layers that has been, some parallel works are being done, but the industrial trend, and we could see that many of the IoT stack applications are focused on the front end, especially on the data analysis. And this is partially contributed by the trend of AI that become a mainstream in pushing IoT to the edge. So a lot of enablers of IoT today, like we have chip sensors, chip bandwidth, and chip processing, which actually make our life easier, especially if you want to embark on any projects related to IoT. We have smartphones as our personalized gateway. We have the ubiquitous wireless coverage, big data, and IPv6, the way we handle the Internet Protocol standards. So all these contributes for the development of IoT in a whole holistic way. So in a nutshell, we can say that IoT is about heterogeneous interconnected objects. Of course, they need to perform some rapid and real transaction, but the real philosophy of IoT is not in the connectivity, but in the services, especially the intelligent services that we would like to offer. So probably one day that there could be a scenario that we could connect the non-physical to the physical world. So let's say we misplace an object somewhere, and then we are looking for the object, we are searching for the object. I think we just need to open the Google search engine and start looking for our devices then. So that could be the final verdict of the vision of the IoT ecosystems. So in IoT objects, right, there are many ways of doing it. if you look at this diagram here, this is actually a racket, okay, that being used to play tennis or badminton, traditional racket. So normally traditional racket is merely for games, right? But when we talk about transforming the traditional racket to an IoT objects, so here we need to add some batteries as power supply. We might need to add some sensors like accelerometers, gyroscope, right, magnetometer. We need some storage, probably an SD card. So what happens now, the full transformation of this traditional racket has become an IoT enabled racket. But the question is that, is there a clear problem statement for us to change the traditional racket to an IoT connected racket? And what is the purpose that we want to change the IoT connected racket? So these are the questions that I think has to be clearly defined in any research problem statement, because there must be a clear way to why we need an IoT connected racket. Probably we want to measure the player's performance, or probably we want to measure the player's data, like vital sign data. And that makes sense why we need to transform the objects to an IoT-enabled objects. So this is very important considerations, especially when we work in any consumer-centric IoT. So apart from that, once we have the IoT objects, the next step is, of course, how do you link them into a linked data space where a lot of data collection has been available through these IoT objects. And of course, there are data sets, like storing them in CSV format, okay, and then creating a nice dashboard. And then finally, the final destination is about analytics and to find the solution to the problem that we are seeking, right? So there are, of course, a lot of support platform, okay, like catalog, search and query, and this is part of the platform and tools that we use when we develop an IoT objects. So for example, I think the most well-known example of putting up IoT sensors or IoT objects in a non-computing device is actually the Nike Plus shoes. This kind of shoes comes with the sensors that tracks down individual running pathway and sends the data to their iPod or probably their mobile phone. It has their own social network and they can post a status report on their social media. So wearable device, okay, and if you look at the consumer-centric ecosystem, wearable device is actually an important enabler for the consumer-centric IoT. Unfortunately, we see that many of the current focus of the wearables are on the fitness tracking, right? Especially on the sports, and to a certain extent on the fashion side for the entertainment, right? But majority of the products in industry, in the market, is all about the fitness tracking. I think that there is a growing trend in how we see this wearable device in future. Partially, of course, from the fitness tracking, they are very much closely related to the smart healthcare, where we have the fitness tracker being used as data collection objects that actually provides real-time monitoring, some sort of emergency response for the patients remotely, connectivity among the stakeholders, and of course, providing remote access to healthcare. Okay, this is available at the moment, and this is something that we have a clear use case. But I think there are more than that actually the research community can embark on. For example, in agriculture, how do we use consumer-centric IoT objects and wearables for agriculture? For example, okay, can we design a wearable shoe for farmers? So why is it important to design a wearable shoe for farmers? So we know that in agriculture, we deal with a lot of data like soil status, moisture, temperature, humidity. So when you have this kind of wearable shoes, so there is an autonomous way of collecting those data, because by just wearing the wearable shoe while the farmer is doing their routine, they are indirectly collecting data in real time. So this could actually, there could be some novelty in how we apply wearables in this kind of domain, especially in agriculture. So apart from that, this can be extended to other instrumented field, like coming up with the proper dashboards, using drones for mapping, and of course like harvesting predictions. And this could be a byproduct once we have this kind of IoT objects or wearables in the farm. So we have a lot of consumer products in IoT. Some of these we might heard about, some we might never heard about it, right? For example, like Nest thermostats, like wireless cardiac monitoring, embed development platform, and so on. Surprisingly, all these products comes from the university, and this comes as a startup products from the fresh graduates. And for example, the first one, the Nest thermostat, was actually a startup product, but later it was bought over by Google, right? So a lot of new ideas are actually from the university itself. And I think it's high time that we need to nurture how we can come up with this kind of IoT object products that actually suits the local problems. So there are, the industry is hyping the Internet of Things, and with billions of devices predicted. So like, for example, the essential elements, or what is the application? Why would a consumer want the device? How does it connect to the world? What is the intelligence, and why they need those intelligence? Can they trust the devices, and so on, right? So it's important for us to understand the design flow, right, before we understand the purpose of having consumer-centric IoT devices. So in general cases, and it's what's happening in industries that companies or industry that actually involves in IoT services, they actually comes with the specification of the concept, then they embark on the high-level design and some design analysis and so on. But today, we actually are very fortunate because of the availability of the low-cost microcontrollers, which actually cut short the development phases. And most probably, we don't have high-level design anymore, and we even don't have the component-level design, but we could immediately embark on the client integrations, especially in developing the dashboard. And this actually really reduced the time to market of the IoT device in the market and industry scenario. So a lot of time previously was spent on the writing device driver, on the component assembly, which has been, we are very fortunate today that this has been enabled by the availability of the microcontrollers today, open source microcontrollers. So like the only thing that we have to focus is actually the field testing, maybe probably some software testing phases, couple of software, and then finally the productions and so on. So what's happening in the academic arena is that, especially in the computer science focus, is that a lot of work, a lot of research problems are now focused on the cognitions and infusing the cognitions, or what we call as smart IoT, combining both AI and IoT. And this is how the infusing of the intelligence into the physical world and try to learn from it. So this could make the product much better from time to time. And this has been the recent trend. So when we have the IoT objects, the collection of data is the first step, of course, where generally we have a sensor-oriented collections. And then we have the processing of the data. So this is where we could do some reasoning, event-based processing, infusing with machine learning or AI, right? And then finally control, doing some sensing-based actuations or to act upon it. For example, automatically switching on fog lamp in a vehicle when fog is detected. However, this process is not that easy, not that simple, because we are dealing with heterogeneity. We understand that many of the sensors that we use belongs to different domains. And most of these sensors uses different type of technologies to communicate. The same goes about to the actuators. And then when we talk about sensors, for instance, like in Malaysia, we have Jambatan Pulau Pinang, the Penang Bridge. Okay, they have like around 700 sensors beneath the bridge. So it's not, we are not talking about one or two sensors, but we are talking about high mobility of sensors, like probably in thousands and so on. So like there could be issues like how to name them and address them, like especially when there is a scalability of IoT objects from time to time. And of course, discovering them, right? Looking at some of the mission critical areas, how do we do discovery of the objects? And of course, processing, which is most of the computer scientists work focused here, like how we utilize those technologies, okay, and using some bespoke IoT gateway. And finally, I think it's very important for us to look at the standards as well, because standards sometimes is efforts by many consortiums. So, and when we look at the standards, we understand where the trend is going, especially for research. So these are some current challenges in IoT, especially like large scale of corporations how do you coordinate millions of devices, then dealing with global heterogeneity. And we have unknown device IoT configurations, which comes from unknown owners. So these are some of the challenges that we need to deal in the long term. And this is why we say that interoperability is required, and this is where AI can help us a lot. So heterogeneity means that we are using different protocols, different programming languages, and even different hardware platforms. And there must be a federated way of managing them and to share the data among those devices. So different operating systems, different databases, different data representations, and even different control models can be very hectic for any developers to come up with an ideal federated solution. And of course, today, we have AI that could do the job for us, of course. So, but it's also very important for us to understand how do we can apply those AI into solving the interoperability. So when it comes to different types of interoperability, there are user interoperability and device interoperability. So user interoperability is like the interoperability problem between a user and device, and the device interoperability is the problem between two different devices. So a simple scenario, like when you're using IoT, let's say you have both A and B entities providing a real-time security services. So maybe the A is actually the CCTV systems placed in different country, and while B is another different country. You can say like probably we have one in Malaysia, one in Indonesia, or probably one in Delhi in India, or probably in Tokyo or Japan. And when this entities use different languages respectively, probably the remote users would like to access the real-time services from these devices. What happens is that the user might not know that these devices A and B at the first place exist. They might be in the different terms in terms of syntactic and semantic notions. And hence it's difficult to find those CCTV devices. So for example, the users can't understand the services provided by A and B. Similarly, A and B do not mutually understand each other. So this is a very common problem in industry and especially in real world, because no manufacturers wants to share their API because of the business competitors. But when it comes to research, I think we have a much flexibility and freedom, especially when we deal with this AI and middlewares. We can actually solve a lot of problems rising from interoperability. So for anyone or any scholars, or I think researchers would like to embark on IoT, I think the first, these are the 5 key components that we have to try to understand. So of course, the first is power and storage, security and privacy, microcontrollers, sensors and actuators, and finally connectivity. So looking at power and storage, Cisco Systems predicted 50 billion IoT devices, but that didn't happen actually. It's just a prediction says that we might hit billions of devices in coming years. So there's an argument says that IoT devices consume less power. Okay, when we talk about microcontroller, it's about 5 volt and a couple of millivolts. Yes, definitely it consumes less power. But when you talk about volumes, large volumes of devices, despite low powers, they could be demanding need or staggering demand for power. Hence, there should be a strategy to look at solutions like energy harvesting and so on. The second problem is the storage, right? And we see that many, traditionally by default, IoT systems pushes data to the cloud. But there are issues on ethics, like for instance, especially privacy as well, where when you have an healthcare or health-related IoT devices, so users might not be comfortable to push the devices into public cloud. And there must be a mechanism to store locally, or something like content aggregator for storing the local data. So we might have log files from sensors that could scale up, and this might be a long-term solution. So this could be an important consideration for IoT objects. Security and privacy is a never-ending problem because we know that there is always a rapid transformation in consumer-centric IoT. And they normally characterize a very data-intensive environment because we are talking about millions of data, right? And of course, they're heterogeneous. They come from different sources, massive. So they should have we should have some sort of effective data protections needed to prevent confidential information, right, falling into wrong hands and so on. So definitely when we address the security and privacy, that could be a better acceptance among consumers. Microcontrollers, right, they are very important ecosystem because they bring much needed intelligence of consumer-centric IoT device. They could deliver meaningful predictive analytics and data reductions. So today, like we have like open source hardwares like Raspberry Pi, Arduino, BeagleBone, Intel Galileo, a very common IoT objects, microcontrollers, okay, to get started on. And of course, more than that, we have other bespoke devices like they could have much better performance. And normally, looking at the price range, they're quite not to say very cheap, but they're affordable. Okay, especially for student projects. Okay, especially Pi, Raspberry Pi, Photon devices, and so on. And we are not today. We are not just dealing with microcontrollers. We also have wearable devices which can be programmable, right? And this is a good news for any makers. So these are some of the examples of bespoke IoT bots that could be fostered to develop any IoT objects. So the good news is that today, with the popularity of AI pushing the IoT towards the edge, we have a lot of custom machine learning hardware today that is available in the market that can be used to develop, I would say, bespoke solutions for IoT objects. So like NVIDIA, ARM, Xilinx, they have both for cloud and edge devices. Despite edge has become very popular due to their miniature size, and they are more powerful than the cloud counterpart. And these devices is expected to replace the MCUs, microcontrollers, in the next 5 years. So sensors and actuators, the fourth component, are important to detect, gather, and measure data. So choosing the right sensors is very important, especially looking at your problem statement, right? So like we have cheap and compact sensors technologies today, ranging from biosensors, thermal sensors, photo sensors that deals with light, piezoelectric deals with audio, image sensors, gas sensors that deals with the gases, humidity and motion sensors. And this could be a good start for any IoT objects kind of projects. And these sensors are actually off the shelf, so it's pretty much easy to obtain them anyway. And then the final aspect is connectivity, where we know that IoT crosses a broad range of data rates, and it could leverage on many communication technologies with always on. We know that Wi-Fi has become a default protocol, but even now we have Bluetooth for low energy, BLE. It's also rising choices for most of the IoT projects with AI. So we have other connectivity options like LoRa, Sigfox. These are mainly protocols by different consortiums. Might not be used, might not be explored much in academics, but I think in industry we are these are some of the common protocols that being deployed. And looking at IoT and smart homes, right, when we try to embark on IoT objects, the smart home can be a very good use case to get started when you see how to connect your home appliances to the internet and how to control them using a dashboard and doing a simple data collection. And by having those data, you can do a classification and see different attributes or the type of data that you want to extract. So this could be a good use case. But when it comes to real implementations, like especially in countries like Asia, like probably in Indonesia and Malaysia, smart home might not be a very strong use case, right? Because any IoT projects that we need to embark, there has to be very strongly connected to the local context and cultural context. So like in Japan and US, and you can see that smart home is a very popular use case, and even every industry that involves in IoT, they normally release a white paper on smart homes because there is a very clear business case for that. but probably not in Asia. But in Asia, we could see the smart city or smart villages are more dominant, and this particularly contributed due to the cultural context. I think that's very important for us to understand so that we know what's the best for the people.
So excuse me. I think we have a bit like some of the questions already on the chat box. Would you mind if we jump into the question and answer session in maybe 5 minutes ahead?
Sure.
So, thank you, sir.
So shall I go for the questions first?
If you don't mind, because we have a lot of questions because our participants actually curious about the topic.
Oh, okay, sure. Okay, so I'll go to the first question.
Do you want me to read the question?
Yeah,
or you?
Yeah.
All right. So the first question comes from Mr. Mahmoud Sulistio. How can the integration of AI and IoT technologies enhance the overall consumer experience in everyday life? If it is still a challenge now, in your opinion, how much longer will IoT or AIoT be able to fulfill it?
Okay, thank you. Yeah, okay, definitely AI and IoT, right? Or we can say the AIoT would be able to fulfill that. But it just we need to see the consumer experience based on the acceptance. There isn't much products today that actually embark on AI and IoT yet. But I think we might see that. We might see that probably in the next 1 or 2 years. And probably that could be some offerings from the telcos itself, telecommunication companies, because they deal with a lot of AI and IoT products at the moment. So coming back to the question, if it is still a challenge now, how long will AIoT be able to fulfill it? So it's very difficult to predict that because it's all about acceptance. But there are some space on what we can see, like how people accept ChatGPT, as part of their productivity. So there might be something on IoT and AI that we will see in coming years.
Okay, well, that's interesting, sir. So, Mr. Mahmoud, do this answer the questions for me?
Yes, thank you. Thank you.
All right. Professor Tinagaran, anyway, so we have also the next question. It's also interesting. It's talking about the big problem in IoT, that is interoperability challenges, sir. How do you think, or maybe how to solve this problem in your kindly opinion, sir?
Thank you. Okay, as I told you, that as I mentioned in the slide just now, interoperability is a big, very broad scope. Because when you talk about interoperability in IoT, we have to go through the layers, several layers, and there is a technical interoperability, there is synthetic interoperability, there is semantic interoperability, and so various levels there are issues. But what we as end users, right, we are looking at the applications, or how do we can have some sort of cross-platform kind of thing. So this could happen, but this normally depends on the standards or the standard released by the consortiums. Like for example, when you have Apple devices that don't talk each other with Android. So the same scenario we are facing in IoT, and that could be one reason why we see a lesser development of products among IoTs, because there are too many players, less products, and less solutions between the manufacturers. So to solve the interoperability, I think we have to start with the lower level, the technical interoperability. And once we could solve that, I think then we can go step by step.
I see. So that's the question actually come from Mr. Risnandar. So Mr. Risnandar, does it answer the question you delivered?
Yes, that's enough. Thank you for your answer, Mr. Tinagaran.
All right, so Professor Tinagaran. Well, I think the participants are really interested into talking about this with you because we have a lot of questions here. Please allow me to deliver the next question as well from Rika Maulida here. How can customer-centric IoT change the way we interact with technology every day? And what are the rules of users or consumer participation in the development of consumer-centric IoT in improving the quality of the life of consumers? That's interesting, sir. So please take your time, sir.
Consumer-centric IoT, they could change the way we interact with technology by having I would say a custom or priority-based or preferences, right? Something like generally when we talk about consumer-centric IoT, it's all about comfort comfort dealing with your daily productivity or the way you deal with the devices. All right. A very simple analogy is our mobile phone, but mobile phone today has become a multitasking device. They are not very specific. But when it comes to IoT centric, this could be something that reduce your expenses in terms of energy consumptions at home, probably the way you use your electricity, something like that. So this could be some I would say some possibilities that we can use as consumer-centric IoT to change the way we interact with technology. And of course, the roles of users is like the way you deal with the data, the kind of data that we provide. So, and by having those data, we can see how it can improve the quality of life of consumers. So it's a very broad and I would say a very broad horizon for the consumers to accept the consumer-centric IoT until they trust and they could accept, just like we accept mobile phone as part of our life. And we need some real applications that actually can contribute to the comfort level for the users.
Okay, so Rika Maulida, does it answer the question, or you have any further question about this?
Okay, sir. Thank you for the explanation.
Okay, so ladies and gentlemen, I think we're also still have some good questions. This one is coming from Aldwin Fikar Ananda. He asked you about, I want to ask a question regarding the role of students. So because Edwin Fikar is currently a student for the development of IoT. So the role of the students for the development of IoT, what contributions can college students make to the development of IoT in the future? Maybe you as the experts in this field, you would like to, let's say we talk about some years ahead from now. So what would you like to recommend to those students to do maybe from now on to develop, like we talk about the future? So, sir, would you please answer the question?
Thank you. Thank you for the question from Elwin. Right. I think the best thing is that to find a domain that is very close to us. Right. For example, if you're on the campus, in the college, you could find some good problem statement surrounding us. Right. For example, like waste management or trash control. This could be a project that you develop using IoT, and you could start collect data associated with it. So, for example, you can see the waste volume in the college, for instance, or the waste volume in the campus itself. And you once you have the data, and let's say you have archived the data from years, then that data can be very pricey, and then you can do a lot of wonderful things based on the data. So this kind of project is something that I say, look around us, look around you. Some clear problem statement. It's not necessarily you have to find something very difficult out of the school, something that very close to us. So I think the campus itself, the college itself can be a good test bed for the students.
Okay, wow, that's interesting. So don't, let's say maybe we cannot change the word like exactly in the big aspect, right? So just look at the closest to you, what you can contribute for the closest aspect. Wow, that's interesting, Professor. Well, this question comes from Soma. What are the current trends? I think maybe it more or less like related to the previous topic you have been discussed, but what are the current trends and future predictions for the growth of IoT, do you think, sir?
Okay, the current trends and future prediction of growth. We will see more IoT devices becoming miniaturized, smaller, and they could be like embed together with AI. So like in the last 10 years, we normally heard about neuron chips, and this could be the next level where IoT and AI become one. So they could be like you could have hardware platforms that become one. So probably IoT chips could be very common in our desktops, in our mobile phone, or any appliances around us. So this could be the next growth for IoT.
Okay, so we can jot down from now on that it's going to be the trends in some years ahead. It's about IoT chips, right? So here's the last question. It's very interesting. The question comes from Shaiful Nizam. In the context of IoT, hardware components play a crucial role in enabling the functionality and capabilities of IoT systems. two key hardware components commonly associated with IoT are cloud computing and edge computing. This question is, can you explain the concept of edge computing and its significance in IoT systems? That's interesting. So please type your terms.
Okay, so by default, we see that many of the existing IoT systems deals with the cloud. But what is happening now that we do have some bottleneck with the cloud, especially on the latency, the resources, and having cloud resources is not cheap. So switching to edge computing is actually you're bypassing the cloud and you're trying to process the data before it goes to the cloud. So having edge is very much convenient, edge devices, because especially when you use AI techniques, you could save a lot of resources in terms of latencies, throughputs, when you have edge computing with IoT. So this edge computing with IoT is very significant in IoT systems. And today we see that a lot of edge devices today are doing the processing rather than pushing the data into the cloud. So it's a good trend, but what's going to happen is that many of these edge devices will evolve and they will become their processor itself. And if you see the latest recent trend that many of the edge AI, there is a new device trend introduced in the hardware community. They call it edge AI devices, which could be the next big thing for the IoT systems.
Okay, well, that's interesting. So, all right. So, well, anyway, actually, we if we could have more time, we would like to spend more time, of course, for this extraordinary discussion with all of the participants, because we're interested into digging more understanding about this. But unfortunately, Professor Tinagaran, anyway, we would like to give you maybe some times to like giving more about what you are talking in this topic, to the participants, please, sir.
Okay, so I think I have another few minutes, okay, 5 minutes.
Sure.
Okay, so I'll just wrap up. So based on the discussion, I think those are the first steps behind the IoTs. Like first, we deal with the device platform, then of course choosing the right microcontrollers, and then working on the software for device API, a bit of connecting, networking, server and web programming, then of course cloud, and today is about edge devices. And finally on data analytics, visualization, machine learning. So this is a very holistic, it's very broad, and one need to narrow down on the aspects where we actually want to work on this kind of IoT objects, right? So like there could be some implications, right? We will see that leading companies will use IoT to gain competitive advantage. So there could be result in new innovative applications and services. So to benefit from data streams from IoT, it will have to effectively deal with large volumes of data. So normally we used to see very common use case like smart home, smart cities, waste monitoring, which is very much urban centric, right? But I think it's about time for us to see a real problem, something like forest fire detections using IoT, or maybe landslide prevention, or even river water quality improvement. This kind of projects which makes sense and I think could contribute more to the community, right? So this could be the implications in the long run. So I will just wrap up that in the past, I think we see that lots of solution has been there, and there's been very little interoperability, right, between these solutions. So presently, a lot of proprietary solutions are still there, but standardization is helping us to wrap up all the layers. So what we expect in the future is that the integration to be finalized together in the standards, and this can make a way forward to realize a better consumer-centric Internet of Things, right? So these are some of the resources that I used in the presentation today, basically on the protocols, okay, on the standards, and some of the articles. Thank you, everyone. Terima kasih.
Wow, that's amazing. So ladies and gentlemen, let's give applause for Professor Tinagaran for this amazing session. Of course, this session was a very wide opening eyes for everyone, for all of us. We might be overly focused on the end user, but we also sometimes forget the journeys where the technology actually too many parties does influence. There's a lot challenging, of course, not simple operation steps in IoT, especially we have to get ready also with the challenges such as heterogeneity and then different operating system, different databases, different control models, and so on. And ladies and gentlemen, unfortunately, we do apologize that since we have very limited time, we couldn't provide further question and answer session for this first session. But please allow me to recap some short of the points that we have been discussed in this session. AI plays a very great role in life. We all know that AI can help IoT to empower consumer with the better home industries, or maybe help automation, improve healthcare, and also intelligent transportation solutions, and many other fundamental services. Application design, network communication, and platform architectures, as well as emerging paradigm of big data, security, and privacy are the valuable understanding for consumer companies to compete in the new reality in which it will be mostly influenced by IoT technology and application. And also, the last consumer industries need to think of the larger possibilities, and this is how interoperability comes into the picture. So once again, thank you so much, Professor, for this amazing session. And we're going to, of course, to come and catch you again until the second session. Professor Tinagaran, thank you so much for this insightful and, of course, valuable knowledge that we got from this first session. So, ladies and gentlemen, that's the end of the first session, and we believe you have gained much valuable insights from Professor Tinagaran, and of course, on the consumer-centric Internet of Things. Thank you, and of course, ladies and gentlemen, as we have promised you all, you will still gain more insights and knowledge, and of course, come follow us. We present to you all the second session of AI for Everyone webinar series 2023. In the second session, we'll learn about technologies and applications of AI and computer vision in medical field. Never forget, we also would like to invite every one of you to actively involved in the discussion by delivering your question, by delivering it directly to the speaker or typing it on the chat box, okay? And don't forget to grab the chance of getting the interesting souvenirs from the committee for the most interesting questions. Okay, so ladies and gentlemen, let's start the second session. The second session will be delivered by Mr. Edward Ferdian, PhD, from School of Computing, Telkom University, who will be talking about emerging technologies and applications of AI and computer vision in medical field. Okay, so before welcoming the speaker, please allow me to read the speaker's profile. Mr. Edward Ferdian, PhD, currently serves as a university lecturer at School of Computing, Telkom University. He also works as a computer vision analyst at Auckland Transport and a professional staff at Auckland Bioengineering Institute. He also has a very rich professional experiences, ladies and gentlemen. Among those are as the research intern at WetaFX in 2022, as a research developer in the University of Auckland in 2021, as Scrum Master or Full Stack Developer at Canon Healthcare from 2015 to 2018, and as a software developer at Gridline from 2008 to 2014. Mr. Edward was awarded a PhD in Anatomy and Medical Imaging from University of Auckland in 2022. His thesis was on motion and blood flow analysis of cardiovascular MRI using deep learning, while his master's degree was pursued from University of Amsterdam in Master of Medical Informatics with the thesis on automated ventricular segmentation using active contours for severely deformed brain in 2015. His bachelor's degrees were from Hogeschool in Holland. I'm sorry if I mispronounce. In Information Technology and Bandung Institute of Technology in Informatics Engineering in 2018. Wow. So we're so proud and we're so happy to be able to learn from our second speaker, Mr. Edward Ferdian, PhD. But before, please allow me to greet our speaker for today. Hello, good afternoon, Mr. Edward.
Good afternoon.
Hello, sir.
Thank you for the introduction.
Okay, sir. So, well, anyway, some of us call you Mr. Edo, right? So,
yes.
Well, anyway, Mr. Edo, time's yours. Please take your time.
Okay. Yeah, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Thank you for the introduction and thank you for the previous talk from Dr. Tinagaran. It was really interesting. Let me share my screen. Right. Okay. Right. So yeah, today I'm going to explain a little bit in brief about emerging technologies and applications of AI in various fields, and especially in medical imaging. So the outline of this talk is mainly about the introduction of what is AI and some applications of AI that we currently have and what we've seen in the past few years. And after that, we're going to dive a little bit about the timeline of AI, and a little bit of computer vision, and also generative AI, because that's the hot topic nowadays. And after that, we're going to see also what kind of AI in medical imaging in general. So not really in the medical field in general, but really specific to medical imaging, and what are the challenges and future directions of this. Right. So when we're talking about AI nowadays, we are mainly focused on ChatGPT, right? Like as mentioned by Isal before, when we're talking about AI, okay, it's about ChatGPT. So what kind of other AI that we know other than that? Because AI actually has been out there for decades, for several years, of course, for a lot of time. But nowadays, because our focus on ChatGPT, we kind of forget what happens before, like what happens in the past 10 years, what happened in the past 20 years. And AI actually has a lot of potential to transform various fields. Because of this, the rapid advancement because of AI has been tremendous. And because of this as well, AI can address complex challenges where it can actually speed up a lot of process. And it drives innovation, again, like ChatGPT or image generation, we can now generate a lot of content automatically, right? So just as a reminder, like AI applications have been with us for several years, have several decades. We have now face recognition, which is very common in your smartphone, and we have now customer service, which is like powered by AI. So you can now chat instead of with a real human, you can chat with a bot, and it can actually help you. Taking a look back a little bit, like 4 or 5 years ago, there was this technology called deepfake. It was booming that time, and everyone was astonished by this technology, right? But we went through that phase. This kind of technology is now normal. Like deepfake is not a thing anymore. Like people have gone through that, and then we move on to the new and shiny object now. So this kind of hype has become a norm now, has become a normal thing. So after that, there's like more applications coming up. Let's say something like this, where you can basically simply draw a cartoon character here, where a children drawing in this case, where it, but using the power of AI, it can actually generate some movements. It can generate some dancing movement, flying kick, and waving, and so on, right? Later on, AI has been evolved more sophisticated, where here by OpenAI, we can actually train machines or computer program here to actually play hide and seek. So you can see over here, right? So you can see over here where the blue ones is trying to hide from the opponent team. And later on, we also see this video in the internet where you can see dancing robots from Boston Dynamics, right? This has been a few years ago, but it seems very recent for us. And this is just a reminder that the improvement because of AI has been tremendous. Not to mention that for a robot to actually dance, it should be able to stand in 2 feet. That is actually a difficult thing to do. In 2020, there's also this advancement in AI where some researchers built a configurable organism where they can actually configure what the shapes or what the functionality of some organism made by skin cells. Right. In this case, it was called Xenobot, which is also called the living robot. It is biodegradable. It can clean the ocean plastic, and also potentially can have a function to deliver drug. So it comes with different specification that can be configurable by AI. And this is just a small video how it can clean some particles on the glass. So, okay, how did we get here actually, right? So we saw this a lot of all of this different various applications of AI. How did we get here? We now live in the age of big data, where data is now in abundance, where we have a lot of data collected, but we don't have that much time to process data. Data collection comes from the internet or even from wearable device like IoT devices. And we know from this data, the computer can actually learn. Computer can learn using machine learning based system. Right? But how come it can learn? How was it before other AI system before machine learning? So let's take a look a little bit on the history. Right? So let's not go too far, but let's go starting from 1997, when there was Deep Blue system that actually won the chess match against Grandmaster Kasparov. In this time, the AI system actually is something like a search algorithm. It managed to search 100 to 200 million positions per second. So it's more of a search function. It's like a search tree that it can actually evaluate all the possible positions and then evaluate that to actually win the game. So the question arises, like, was it actually aware of how to play chess? Was it actually aware of chess concepts? Does it actually have intuition, or is it just merely a search function? Can it actually recognize pattern, right? So from then, people start to develop other techniques such as machine learning, and then actually learn from data itself. The breakthrough of machine learning, especially in computer vision, is actually on 2012, where AlexNet won the ImageNet competition. So in this competition, AlexNet, it was a competition of we're using 15 million images, where it contains 22,000 classes, right? So AlexNet is basically the first deep CNN, or convolutional neural network, that revolutionized image classification. Right? Back then, it is considered deep, while it actually consists only using 5 convolutional layers. It has 60 million parameters, and the key point here is actually it's optimized using GPU, and that is actually the breakthrough why the system later on actually utilized these concepts. So the idea of convolutional is actually very, very powerful, because it actually utilized the spatial neighboring relationship, so it can actually learn how to process images, because otherwise you have to process it in a pixel basis, where it is actually computationally expensive, right? So after this AlexNet, there's actually more networks being developed. We learn more about how this layers, how this relationship works. And then layers are getting deeper. So it starts from 5 convolutional layers like this, and then we go to VGG16, which is 16 layers. And then we have ResNet 50 layers, and so on, right? So networks are getting deeper. And as far as this, we also learned a lot more about how neural network works, especially in convolutional networks, because now we understand more about how we actually process information. So we process information within different layers, within different stacks, and these different layers actually have different abstractions of the object, or of the context within an image, for example. So this is one popular network that is still ongoing until now. So nowadays it's YOLO V8 probably. So it's capable of real-time detection of multiple objects. So not only it can classify one thing, but it can also detect multiple objects at the same time. At that time, it consists of 24 convolutional layers. So again, it's much deeper than before. So the term of deep learning here, like deep convolutional network, has changed a little bit. Like before, five layers are considered deep. Nowadays, 5 layers are considered very shallow, or shallow network, right? So networks are getting deeper. So based on this, we also learned that abstractions from layers are actually just like how actually a human perceives things. We actually look, let's say, on the foreground, on the background, and so on, right? So, and all of this are actually called discriminative learning, where we actually try to find what thing can discriminate certain objects from the other one or certain features from the other one. So other than discriminative learning, there's also other thoughts of AI or thoughts of learning, which is called generative learning. So it's generative AI, and this is a branch of AI that aims to create new and original content, such as images, music, text, and even code, right? So the first iteration of generative AI in terms of deep learning is called the GAN, Generative Adversarial Network. Its aim is to generate a new set of data. So here is a Twitter from Ian Goodfellow, which is basically the one that coined GAN in his PhD. It was his PhD thesis. So he put the progress of GAN for 4.5 years. It started with a very blurry image. It gets better in 2015, and it gets better. And finally, in 2018, it gets like very, very realistic. But however, GAN is very difficult to optimize because how the model was built, right? But this is actually the beginning of generative AI, where it can generate really new content, new data. But again, something is missing from this because the result of GAN is not very sharp. Right? So in 2017, this is the breakthrough that actually changed the landscape of AI. It's called the attention mechanism. So attention mechanism is a very simple concept, but this idea is actually changing a lot on how all the system works. Because the idea is basically when we, as human, we focus on the most critical aspect of the data, right? We can put attention to something. When we see a picture, we can put attention on certain object. And we are also able to actually ignore certain parts of the object. And this is exactly what attention mechanism do. It mimics the human capacity for selective focus. And it is applicable to a lot of different fields, from text, images, and everything. So based on this attention mechanism, there's a multi-head attention. There's also transformer, which is basically the base or the building block of all the fundamental AI model nowadays. All right. So now in 2021, there's from OpenAI, there's a GPT-3, which is Generative Pre-trained Transformer 3. Right, so it consists of 175 billion parameters. It's utilized this transformer concept with it can actually process a lot of corpus, a lot of text, and build a large language model out of it. Right, so back then, this is more than 2 years ago, right? GPT-3, this is before ChatGPT. This is really a huge thing, right? This article is written by GPT-3. So a robot wrote this entire article. Are you scared yet? So at that time, this was such a big deal. And also there's an example here where you can actually put an instruction to create a Google homepage. Of course, there is no chat capability yet, but this breakthrough show a much larger capability of AI in terms of language model. Right. On the other side of image processing or computer vision, transformer is also utilized to create as a baseline to create something like diffusion model, right? This is, you might already see DALL-E or image generation nowadays. This is the first version of DALL-E, which comes out in 2021. It can basically generate images from text and also adjust the styles or features into different images, right? So all this concept is based on something like diffusion model, right? So what is diffusion model? How can it actually do that? But you may already heard now about like stable diffusion, latent diffusion, and so on. There's a lot of variants because it's open source. But let's take a look what is the base or what is the idea of diffusion model. So the diffusion model idea is actually very simple, right? So there's the forward diffusion process. There's also the reverse diffusion process. So the forward diffusion process is basically you have a certain data or a certain image in this case. This is a picture of a dog. And you basically destroy the data by adding a small amount of noise. And you do this, let's say, for a lot of time step. In this case, let's say do it for 1,000 steps. And after 1,000 steps, the image is purely noise. So it's nothing, it's completely destroyed. Now the diffusion model is basically learning. What it learns is to learn to recover the image, or basically removing a small amount of noise from the image for each time step. So it does this in a sequential step. So it's very iterative, right? So you can imagine that it does this like 1,000 times. So once it's trained properly within using a certain data set, using, for example, this dog image, then it can actually generate a dog image out of nothing, right? So once a diffusion model is trained, basically you can generate anything depending on the trained image. So that's how basically diffusion model works. And now then you can see something like this, right? With generative AI, there's a set of algorithms that can generate anything: images, text, video, audio, or even code, right? It's guided by user specifications, where what you call prompt, and it's also guided by the training sample, right? So it's the language model is basically the example is ChatGPT, while the image generation example is something like this, from DALL-E or Stable Diffusion. Right. So some other examples of generative AI, right? So this used to be impossible. Nowadays, if you want to change a drawing or a painting from, let's say, here on the left side, you have a picture of a horse here. Then you can change it using a prompt, a robot horse, or anything else, and the AI can generate it for you. And other thing, which is like extrapolation, where it is impossible before, or it's very hard to grasp how it can actually extrapolate some data, because interpolating is easier than extrapolating. And then nowadays it can basically paint a whole picture, of course, based on the trained data, right? Or for some of us, of course, like developers or students that are actually love to code, there's now automatic code generation. You have GitHub Copilot. You can actually put a language prompt like this, get Pokemon data from the web, and save it to a file or so, and it will basically generate the code for you. And the idea is not to replace programmers, not to replace coders. It really just basically it helps to cut the time spent on low-value tasks, so you can focus more on the bigger picture, right? So this is again, it's trained on a lot of codes available online, including public repo in GitHub. So you can utilize this, and then generative AI nowadays has become a big thing, right? We even forget like how was AI before this, right? So now to go back to that, because it's a hype now, where is it actually in the hype cycle? So as you can see, generative AI is around here. You can see also it's the light blue dot here. This is from Gartner.com, and this is from July 2022, which is last year, roughly. So you can see probably within 2 to 5 years, it will actually go to the plateau of productivity, where we can actually go through the hype, and actually we know exactly what are the limitations, what are the advantages, and we can use it for more productive thing, right? Other than that, there's a lot of other things here, and a few things here are actually also related to generative AI, like natural language processing, which is basically in collaboration with generative AI to generate text, and also synthetic data, where it can now generate a lot of synthetic data, right? And one thing here, physics-informed AI, I'll discuss that a bit later. That's for a little when we touch the medical imaging side of things. All right, so that's all about like a little bit of the timeline of AI and how AI has shaped the field, and especially with the hype of generative AI, right? So let's take a look in a little bit at medical imaging now. How are things in medical imaging? So because it is probably not very common when we study in informatics or computer science to touch something like this. Right, so this is a picture of an MRI of the heart, where you can see the heart is beating, right? So this is basically an image captured or acquired using MRI machine. It's captured over several frames, right? So AI in medical imaging. Medical imaging is basically the visualization of body parts, tissues, or organs for clinical diagnosis. You probably have seen some kind of these images before, but what are the differences? Right, so the differences in medical imaging, this is called the modalities. Modalities is basically the different types to acquire the images. Here you can see X-ray, you can see a CT scan, you can see an ultrasound or an MRI. But why do we need all of this, right? So different modalities have different capabilities. So X-ray is good in acquiring or for image acquisition to visualize the bone, for example, for bone structure or for heart structure, and CT is good for like showing contrast between different tissues or different bones, something like that, right? So each of the imaging modalities are having their own advantage and having also their limitations. For example, like here, ultrasound, while it is very easy to acquire, very cheap, but the image quality is not very good. So the idea to have this medical imaging is to, of course, to diagnose pathologies or disease detection, but also it's able to non-invasively quantify clinical parameters, right? Otherwise, you have to stick a needle in your body and or calculate pressure inside your body or so on. But with medical imaging, you can basically do it just by scanning your body, let's say, right? So, and it's also useful for guiding medical intervention, and of course, for a lot of research have been conducted in this field. Right. So now talking about AI in medical imaging, what are the problems and applications? The main problem and application is, of course, the basic one is segmentation. It's like it's in every other field. It always starts from segmentations, and later on, because of most of the data in medical imaging are 3D, we are trying to do 3D reconstructions. On the left here, we can see trying to reconstruct the left ventricle chamber of the heart. So we can go through the echo. As you can see, it's very, very difficult to see where the boundary is. And then with the help of AI, we can actually reconstruct this and then put it in 3D, right? And also we try to do image enhancement, where here we can try to enhance and then see how blood flows in the body. So we can visualize the velocity field. So this is not real blood, but it's in terms of velocity. So we can see the jet of blood going through the different section of the vessels. And from here, we can actually quantify and measure a lot of the clinical parameters in order for the clinicians to actually help to diagnose and then help through the disease. So the challenge on this is, unlike in computer vision or any other fields, we are lacking of data in medical domain, because to utilize deep learning, especially we need a large amount of data, especially labeled data, right? The main problem is also because the high cost of acquisition. So MRI machine, if you go to an MRI machine, it costs like $2,000 to get scanned, for example. So it's very expensive to get even one single data, and the analysis is time consuming because the data is not 2D, it's 3D, and then you require like specialized doctor or clinician to actually label the data and so on. And of course, it has patient privacy issue where you cannot really share the data without being anonymized. So there's a lot of challenges required to actually train a model in the medical domain. Other than that, the data characteristics also very different. It's high dimensional, the resolution is very low, and it's very noisy, and a lot of variations in the ground truth. Okay, so some example cases. Let's start with the basic case, how we use AI in medical imaging. So here we have a 3D ultrasound where we have to segment one chamber of the heart, the right ventricle of the heart. So why do we even do this actually? So right ventricle volume is important, is an important marker for cardiac disease. So by knowing this, you can actually, the clinical can help to diagnose the patient. And of course, manually segmenting this from a 3D image is time consuming. It's also very complex, and you cannot really see boundary. So of course, the answer is to use AI, use deep learning. After all, this is, again, is just a segmentation problem. So it's lack of data. So let's see if we can basically use AI. Let's go back a little bit to computer vision, where recently there's a segment anything model called SAM, where it can actually segment anything automatically. You can actually just probe a point there, and then it will segment the object. Or you can give text like this. It can segment all the cats in the image, or it can segment automatically all the buildings here, right? So this new AI model is very versatile. It's robust. You can basically just segment anything. So the thing is, it's also trained on millions of images, and after it was being trained on million of images, it semi-automatically labeling 1 billion images to retrain the network. So it's very, very powerful. So let's try to apply this in medical imaging. Oh, sorry, skip that. So in medical imaging, when we try to apply just on 2D image, so not on 3D image, which is very noisy, it has unclear boundary, and this is an example of the ground truth. This is from a CAMUS dataset, which is an open set, which is a public dataset for 2D echo. And then when you use SAM, the segment editing model, it basically segments the whole triangle, the whole cone. So the problem with this is off-the-shelf model needs some adjustment, needs some retraining. And again, to retrain this kind of model, we are again lacking data, right? But now that we have generative AI, we can basically create synthetic data using generative AI. So not only it's useful, like to create art or create something fun out of it, but we can actually create something useful, which actually we can create a lot of this medical imaging, and also doesn't have the patient privacy issue, right? So given those constraints, there are already some implementations of synthetic image medical imaging generation, and all of these are based on the diffusion model. But again, there's still like lacking of image quality, lacking of diversity, and so on, because it's really hard to measure how the quality is or how diverse it is without actually a better evaluation metric, right? But we are getting there. There's more and more people spending time on this on the academia in order to create more realistic and affordable and accessible medical imaging. Okay, so, and what are other applications in medical imaging other than, for example, segmentations? And then we touch a little bit about generative AI, right? So what is the end goal of this, right? So some other applications is something like this. We would like to 3D reconstruct some anatomical regions. For example, you have a heart over here, then you can segment it, you can reconstruct the surface, and you can actually reconstruct the whole 3D model, right? So why do we even do this? Because with this, actually, then we can diagnose perfectly, because every person have a different anatomical shape, basically. So when you have this, you can build a personalized medicine or a personalized system that is tailored for you, right? Other various applications other than segmentations, of course, we do a lot of different 3D geometry reconstruction. We can actually quantify a lot of metrics from here, and also surface mapping. We do cardiac mechanics, so how after we construct a 3D model, how we can actually physically correct movement from the heart, let's say. And we can also do flow simulation to actually measure how the blood flow within the vessel, and also visualize and enhance the image, and also quantify the flow in order to actually be useful for clinical diagnosis. So when all this combined, right? So we have all some anatomical region from the brain here, from the heart, and so on. What's the end goal here? The end goal is something like this, right? So personalized medicine, where we can actually build a digital twin of ourselves, right? So, and all of this is an ongoing research where a lot of different specialty from the brain, from the heart, from the lungs, and from everything else try to build a personalized and digitalized version of the anatomy based on the image, and then you do a 3D reconstruction and a lot of simulations. And this can be updated continually as with new measurements that we get from all the imaging protocols. Okay. Right. So that's basically how AI is being used in the medical imaging domain, where we can actually use a lot of the AI capability to actually do a lot of this task automatically and more accurately, and focus more on more complex and more sophisticated stuff. Okay, so other potentials in healthcare, especially, let's say the image to text like ChatGPT. What if we can actually generate text or diagnosis out of the image directly? So not only we can segment, we can get the quantity, we can also do some diagnosis directly from the image to text, right? And again, personalized medicine, digital twin, where we are able to combine all these measurements and then construct a full 3D, like personalized ourselves. And personal health assistance, for example, and also integration with other imaging technologies such as IoT. Now that we can utilize all this and potentially utilize this for the better of the healthcare, also where are we going from here? So these are the following trend in the medical domain. What first is the interpretable AI. So not only it's important that AI can do something, but it's important that we understand what AI do, because in the healthcare, it's very critical that we understand what is it, for example, what is it segmenting, what is it calculating, not only like, okay, we see some good results, that's it. No, we really need to understand how it works. And also synthetic data generation has becoming a trend in the past few years because of its capability in generating new data. So it's easier and then it's cheaper to actually spread the data around. And also physics-informed neural network, where we not only process the image, but we also combine physics information, the law of physics, to understand how heart beats and how physically correct it is. So not only based on pixel values, but also based on really based on real physics. And also because 3D processing is very expensive, we are also looking into image to mesh, where everything is processed within a graph. So to be able to make the data is more efficient. And here you can see an example of, I think this is learning to simulate on a GitHub. So it can actually simulate a water particle over here, and how it actually corresponds with the wall. And also here it's a rendering of a very complex wave system using a graph network.
Dr. Edward.
Okay.
Dr. Edward.
Yes.
Well, that's
Yes.
very interesting, especially to see the water wave, especially that's something really interesting, sir. But anyway, sir, this actually, I'm sorry to interrupt, but actually I think the participants are looking forward to the discussion because there are a lot of questions.
Sure.
Okay, so please allow me to take the time for reading some of the question. It's going to be started by the question delivered by Shah Nazri. Here, it's your opinion, sir. What is the difference then between AI and big data and between AI and robotic if they are the same, and why it's different in definition? So, sir, please, time to answer the question.
Okay, so yeah, so AI and big data, right? AI is really the method, the backbone to actually process all this data. Big data, to me, it's basically the era of big data, and it's the amount of data that you need to process, that you need to collect. And the other one is between AI and robotics. So in terms of robotics, what we saw earlier, like in Boston Dynamics, right? It used a lot of AI system, for example, for the vision, to actually process the input video, input image, and so on. So AI is basically a small part of it. The robotic itself is all the mechanical parts to actually perform the action. So AI is actually let's say the software part to actually process all the inputs and so on. So it's quite different, right? But it helps each other.
I see. That's interesting. It means AI helps the robotic itself. It's into becoming one of the parts in the robotics.
Yes,
okay, sir. This question next come from Ms. Emma Rahmawati, Ibu Emma. So the question is, what are the ethical considerations and privacy concerns associated with AI and computer vision technologies in the medical field, sir?
Yeah, thank you. That's a really good question. Yeah. So in terms of generative AI, because we are now using AI to generate data, right? And this generated data basically, of course, was trained on real patient data. And the question now is the authenticity of the generated data. So to evaluate synthetic data, there's three criteria. The first one is image quality, which you can measure. The diversity, you can also measure using a certain techniques. And the main problem here is authenticity. Does it actually create something new? Right, in computer vision field, it's not really an issue. Well, okay, when you create something that was already on train, something on train with, it's a problem because that's not what we want. But the problem in medical field is if it actually create or reconstruct the complete patient data, then it's an issue. So there's a lot of checks is happening to make sure that it doesn't actually output, or it doesn't actually just push all this patient information out. So yeah, that's in terms of the privacy issue. That's the main problem. And for like discriminative AI, for example, like segmentation and 3D reconstruction model, normally what we do to process the image is the image has been anonymized, so that shouldn't be an issue. I hope that's answering the question.
Okay, so Ibu Emma, does it answer the question? Or maybe you have further question?
Yes, thank you very much for the answer, Mr. Edward. Thank you, Mbak Yayan.
Thank you, Ibu. So, Mr. Edward, anyway, so we still have some questions. I hope you don't mind to answer those questions.
That's
so
right.
The next question, sir, coming from Eko Widodo. So, Prof. Edward, I would like to ask about generative AI. Can GAN help machine learning in the healthcare industry if in the future there is a shortage of data sets for training data? So, thank you, sir. Please answer the question.
Yeah, definitely, right? I mean, we went through that. So GAN, or generative adversarial network, was we attempted to do that, to generate data in the medical field, but GAN has some limitations because the image is blurry and it has lack of diversity and so on. Nowadays we use the diffusion model, where it has more power in terms of creating more diversity, more quality images. But the only downside is just it's very heavy in terms, because you saw in the earlier example, it has to actually iterate through, let's say, 100 time steps or 1,000 time steps to actually reconstruct an image out of noise. Right? In medical imaging, it's not very ideal because the data is 3D and so on, but later on people come up with new ideas where you can process it in the latent space, you can process it in the compressed representation and so on. So it is such a powerful concept, but yeah, I think people have moved away from GAN, but the concept stays there, right? The concept of the balance between discriminator and generator stays there. Even the diffusion model used that to actually improve the quality of the image. So yes, definitely GAN is basically helping in generating data set.
Okay, so Mr. Eko, does it answer the question, or if you have any more question to Prof. Edward? Okay, so I guess I predict it's answered the question. Okay, so Mr. Edward, this next question comes from Mr. Risnander. So Mr. Risnander delivered the question: some potential drawbacks to consider when it comes to the use of AI in radiology. So one concern is the lack of transparency in how AI systems make decisions. It can be difficult to understand how an AI system reach a particular solution. Give us the suggestions. So it's your opinion about this question. So Tam's yours.
Yeah. So yeah, the lack of transparency, it is an ongoing research in medical field, especially because we need to know exactly how AI output the output that it's computing, right? So one way to control this is in a very granular level. So we make sure that AI is specialized on doing one small task at a time. For example, segmentation, 3D reconstruction, quantification, and so on. So we make sure that we know exactly what the AI is doing, one small step at a time, and then we know exactly how it actually reaches the final conclusion. And another way is also, of course, there's the attention model, where we now know much better on how the deep learning, how model works, because we can now visualize what part of, let's say, a certain image the AI is putting focus on. That actually helps a lot. In terms of text, also we have proven that the attention model can actually show the connection between the text, for example, something like that.
Okay, wow, that's interesting. Dr. Edward, anyway, we still have some of the questions, but maybe I just wanted to remind you at the end of this session, we would like to ask you to kindly choose the best three, maybe interesting, most interesting questions in this session. So please kindly, maybe you can try to pick it from now on. So, sir, the next question from Huda Fauzi Al-Shahad, maybe it's a bit slightly we have been discussed about it, but we can have further discussion and maybe further explanation about it. I would like to ask about GAN. Can we use GAN in segmentation image, and what the drawback of use in the segmentation, sir?
Okay, thank you. Yeah, interesting. So segmentation problem itself is actually a discriminative problem, right? If you see the earlier slide, it is a discriminative problem where where the model tries to extract the features or what the difference are, and then discriminate what is the object. So it tries to segment something. So in terms of GAN, in terms of generative way to do that, if you see the segment anything model, it actually combines those two. So what it does is actually use the diffusion model process where it tries to generate something from, let's say, a single click of point. So not exactly GAN itself, but in a generative way, yes, you can segment, but in combination with a discriminative model. Yeah.
Okay, so it is. Okay, thank you, sir. So the next question, again from Ms. Rika Maulida, can AI and computer vision technology improve efficiency and accuracy in the medical diagnosis process? And how will the use of AI and computer vision impact medical practice and the role of medical professionals? So it's going to be a wide explanation from you, sir, but would you please kindly answer this question so that we can grasp? I think it probably the sum up or the summary of the discussion for today. So please, sir, take your time to answer the question.
Yeah, thank you. Yeah. So from the technical perspective, yeah, the answer is, yeah, we would like to really improve the efficiency and accuracy in medical diagnosis, right? I think the question is more from the clinical side of things, where they really want to understand how AI works. Because when we present this to them, okay, we can, for example, again, back to segmentation, we can segment this and calculate the volume of the heart and calculate the volume of how much blood the heart pumps. And they would ask how. And our task is actually to connect this on how the AI can learn from these images to segment something and then actually output something that is useful for clinical. But in terms of AI and the role for medical practice, we are striving towards collaboration between the two, right? Because we cannot just do something in AI without actually understanding also the background in the medical field. So it's a collaboration, really good collaboration between the two, and also a little bit of learning from both sides. From the technical sides, we have to learn a little bit about medical sides, and from medical side, they need to learn a little bit also about the technical sides on how the learning process works. So I guess that's the answer for that.
Oh, that's amazing, sir. Sir, anyway, I think it's the next question is very interesting. It's coming from Professor Dr. Rahmita Wirza. So, Dr. Rahmita, do you want to deliver it directly with our speaker, or you want me to read the question? Professor Rahmita?
Yeah, please go ahead.
Okay, Professor. So please allow me to read the question. Dr. Edward, as mentioned in the slide, one of the challenges of using deep learning in medical imaging is the lack of data, especially the normal anatomy data. And I do not think it's advisable, I'm sorry if I read this, to do the data interpolation as it involved with the accuracy of the processing. May I know, do you have ideas on how to solve this or minimize these challenges? So that's first question. Do you want me to read the second directly, or you want first one by one?
Yes, you
Let's
can read the second one.
Okay, so that's first question. And the second question from Professor Rahmita regarding the segmentation, sir, there are different modalities and different part of human anatomy that needs to be considered. Even segmentation of the right and left ventricular have to use seed points to start the procedure. Do you think deep learning will be able to produce fully automated segmentation to any part of human anatomy, sir? Please time to answer the 2 questions.
All right. Okay, thank you for the question. The first question it's about about the interpolation of data.
Yes.
Right. So yeah, I've been talking about how generative AI can help in producing or in generating more data. There's still some issues regarding to that because, as we know, it's very hard to extrapolate data outside of the manifold. So the problem with synthetic data generated by a diffusion model, for example, while it is diverse enough, it tends to interpolate data distribution within the manifold. The problem with that is, of course, like you mentioned, it is not advisable to use data interpolation as it involves with accuracy. Yes, so accuracy on this is also still very limited, and we are still trying to find a way actually to extrapolate beyond or like generate more diversity on the data. So it is still a big challenge, and it's very early in the research, I guess, right? Because diffusion model was out like last year. Things have been like speeding up faster and faster, and you can see like there's now medical imaging synthetic data already out there, while we are still developing more of that. So yes, so it is still an issue because also like training from synthetic data is also known to cause training bias, where it is really segregated to a certain amount of population. So it is still an issue. Unfortunately, I don't have the answer yet. It is still an ongoing research topic. So for the second question, I think regarding the segmentation for the different modalities. So typically, yes, you're right. So segmentation of right and left ventricle is, of course, different. So typically there's different models that are specialized on left ventricle only, on right ventricle only. And most of the time we are focusing on the ventricle, and then there's very, very lack of research on segmentation for the atria, for example. And all of this anatomic part requires different specific models. And regarding to the seed points, typically when what we aim is without any seed points, so it's fully automated. So it's given an image, it outputs a segmentation directly. The one with seed points is actually only happening recently after the segment anything model. Because the segment anything model provide us a way to actually give us a prompt, or in this case, a visual prompt, not a text prompt, but a visual prompt where you can click. So before that, we use a discriminative model where you have an input, then you get an output directly. Nowadays, you have more control over it, where we can have this kind of prompt, then you can have more control over the segmentation.
Okay, so Professor Rahmita doesn't answer the question, or you have any further question for the speaker?
That's good. That's good. Thank you very much.
Thank you, Professor. Okay, Dr. Edward. Anyway, one last question. Well, actually, we have a lot of questions in the chat box, but unfortunately, due to the limited time that we have, unfortunately, I can only give one last question from Shahnazri here. But before, maybe Dr. Edward, would you mind like sharing your emails to the participants, if in case we have like further questions, and maybe we can have like further collaboration or maybe further discussion with you, if you don't mind, maybe?
Yeah, of course. Yeah.
Okay. Well, that's cool. All right. So, wow. Thank you. Thank you, Dr. Edward. Anyway, ladies and gentlemen, if you have further questions, you would like to deliver questions to Dr. Edward, you can simply like do the correspondence with him through his email. But so it's last question from Shahnazri here. And digital twin, there are 2 directions, from physical to digital and from digital to physical back. I was wondering if there are any studies focused on the latter.
Okay, so probably there is. I'm not really familiar from one side to the other. Because in my study it's more from the medical side to actually reconstruct it into a digital way. So from digital to physical, definitely I think there is someone out there who is also doing this kind of research, but I'm I'm not aware of that. I mean, it's not really my field.
I see. Okay, so maybe later on, if we have a further discussion with Dr. Edward, we can simply having a more discussion and also collaboration with Dr. Edward. So we also would like to kindly maybe ask Professor Tinagaran also to kindly share the emails, because those participants today were very, very amazing, because we're so curious about those topics. And I hope Professor Tinagaran also don't mind to share the emails so that our participants can have more communication with Dr. Edward and also Professor Tinagaran. Well, anyway, Dr. Edward, I wish that I could give more time to the question and answer session, but unfortunately not. So maybe you would like to give some minutes for recapping, or maybe for telling some of the important points you would like to deliver in your topic, sir. So please take your time.
All right, thank you. Yeah, actually, I was almost finished. This is the last slide. So some key takeaways, right? So AI has a net impact as a contribution to society. Whether there's a downside to that, most of the things are very positive, and we have to make sure that we are very responsible in using AI, and it have improved a lot in healthcare and many other fields. Have you seen, like I mentioned in the beginning, we already forgot what happens in the past 10 years, because the changes happen so rapidly. And AI has democratized access to information, where now a lot of data are available, a lot of free data are available, and even someone who cannot really use computer very well can actually do a lot of things with this, right? So, but because of that, tread carefully. Be careful with the information that you get, because most of the information can be generated nowadays. A lot of the images are generated nowadays, and it can create a lot of bias, especially if you are training a deep learning system. Be careful with that, because not everything that is generated by AI is actually correct. You actually have to evaluate that first. So that's all from me. That's the key takeaways. Yeah, I think that's all. Thank you. Thank you for listening.
Wow, ladies and gentlemen, let's give a round of applause for Dr. Edward Ferdian for this amazing session. This is a very wide opening eyes, especially for medical fields, right? So thank you anyway, Mr. and Dr. Edward, for the presentation. So ladies and gentlemen, before closing, of course, I would like to recap and also sum up the session in the second session. Maybe I believe that you gain much knowledge, but I just wanted to highlight 2 points that I can catch and capture from this session. Recent the advancement in AI, particularly in the realm of generative AI, have significantly propelled research and progress across diverse fields. And we believe that within the realm of medical imaging, AI has the potential of to revolutionize disease diagnosis, parameter quantification, and personalized medicine. That was very amazing. So, distinguished guests, ladies and gentlemen, that's the end of the second session. We believe you have gained much knowledge from Mr. Edward Ferdian, PhD, on the technologies and applications of AI and computer vision in medical field. So thank you, Dr. Edward, for the amazing session. But we would like to kindly ask the speakers for these sessions to kindly be on the camera, because this time, we would like to invite both of you to have the token of appreciation, or maybe to accept the token of appreciation from the committee. So distinguished guests, ladies and gentlemen, please allow us to deliver a token of appreciation to the 2 speakers of this AI and for everyone webinar series. And for the first time, we would like to invite the first speaker, Associate Professor Dr. Tinagaran Perumal from the Department of Computer Science, Faculty of Computer Science and Information Technology, University Putra, Malaysia, to kindly be on the camera and also receive the token of appreciation from the committee of the AI for Everyone webinar series. So, ladies and gentlemen, we would like to invite Professor Tinagaran Perumal to be on the camera and accept this certificate from the committee. Professor, thank you so much. And we believe that all of the things you have shared to us, it's going to be the right thing, of course, back to you in written. So we hope that we're going to do more collaborations with you in the future, sir. And of course, we are looking forward for the next collaborations.
Thank you. Thank you to everyone. Thank you.
Thank you, sir. All right. So ladies and gentlemen, we also would like to invite the second speaker, Mr. Edward Ferdian, PhD from School of Computing, Telkom University, Indonesia, to kindly be on the camera and accept the token of appreciation from the Committee of AI for Everyone webinar series. So Dr. Edward, thank you so much for your insights. It was very amazing. And I think we're going to open up more discussions with you, of course, and also with Professor Tinagaran, of course. So thank you, sir, for the insights.
Thank you. My pleasure.
All right. So, well, thank you so much, Dr. Edward Ferdian, and also Professor Tinagaran for this amazing session. So, ladies and gentlemen, we believe all of the participants are looking forward to the announcement, of course, who will get and who will be awarded the souvenirs, interesting souvenirs from the committee. So we would like to announce to you all. Okay, so we would like to ask the committee maybe kindly to share the screen. Do we have the screen of the names listed who got the souvenir? Okay, wait. Okay, so I think we're going to announce it directly, Bu Emma, right? Okay, Bu Emma will announce to you all who will be awarded the door prizes from the committee, of course.
I already read
Oh,
it
you
down
have
in the
sent
chat
it
box.
on the chat
Yes.
box. Okay, wow, that's amazing. I think it's not surprise anymore because Miss Bu Emma already shared it on the chat box. All right, so to make it the vibes like being very, very wow, let's go, ladies and gentlemen. I'm going to announce to you all those 6 participants who were awarded as the most interesting question deliverer. So it doesn't mean that the rest of the participants who have been delivered the question also amazing, but we have to choose 6 participants who gonna get the souvenirs from the committee. So we would like to say congratulations to Mr. Edwin Picard Ananda from Telkom University, Ms. Rika Maulida from Telkom University, Mr. Risnandar, the National Research and Innovation, BRIN, Professor Dr. Rahmita Wirza, congratulations, Professor. And we also got Azri Sahral Ahmad Nazri from University Putra, Malaysia, and Hamza Al-Samadi from University Putra, Malaysia. Wow! So once again, we would like to say congratulations, and the committee will contact you as soon as possible through email. So please keep in touch with the committee, and we'll get a very interesting souvenirs from the committee for your contribution in making this discussion very amazing, also interactive. All right, so honorable guests, ladies and gentlemen, the token of appreciation and also the announcement for the most interesting question has been delivered and also marked the end of today's webinar session. Before closing the session, we would like to remind all of the participants to fill in the presence list link or maybe the form attached on the chat box and put your full name as it will be stated or written on your certificate. So please make sure you don't do the typo or something. And then we also will send the certificate to your email. Therefore, please kindly write your email carefully. And for those who got the door prizes, please kindly touch or maybe keep in touch with the committee, and we will contact you through your email for getting the very amazing souvenir and also door prize from the committee. And thank you so much for everything, ladies and gentlemen. And on behalf of the committee, we would like to deliver a sincere gratitude to School of Computing, Telkom University, University Putra, Malaysia, Seloe, Telkom University, Research Group of Intelligent System, Telkom University, Dean of School of Computing, Telkom University, Deputy Dean, Graduate Studies, Faculty of Computer Science and Information Technology, University Putra, Malaysia. Notable speakers, of course, Associate Professor Dr. Tinagaran Perumal and Mr. Edward Ferdian, PhD, all of the committee for this AI for Everyone webinar series, and of course, all of the participants from Malaysia, Indonesia, and other countries for all of your time and also participation. And we believe you have gained golden experience and insightful knowledge from this event. So to finally close this event, please allow me to close by delivering a poem. You know, pantun, is it also stated pantun in Malaysia? Oh yeah, that's cool. Then I'm going to give you all as the closing statement with a very beautiful pantun. In Indonesia, we usually say cakep. in the middle of it. So you just can simply whisper to yourself. But in Malaysia, what do you say? Maybe you have any specific response to each of the line of the poem? Okay, so I'm going to deliver this poem as the closing statement for every one of you. I know the time is always passing by. Talking about AI, oh, Chaka, Pak Mahmud, thank you. Talking about AI is everywhere and anytime. Ladies and gentlemen, it's not a goodbye, but it's a see you again next time. So I'm Bian Hamidah. We'll see you again in the next webinar series. Thank you. Have a great day. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, everyone. See you
Thank you,
again.
everyone. See you again for the
Thank
next
you,
webinar
everyone.
session.
Series session.
Series session. Thank you, sir. Thank
Thanks,
you,
everyone.
everyone.
Yeah.
Thank you, Prof. Abdullah Muhammad. Thank you.
Thanks.